We are right on the verge of a massive technological shift. So today, we're going to dive into what happens when two of the most powerful, game-changing forces in science, I'm talking quantum computing and artificial intelligence, finally come together.
And that is a huge question, right? When you take the bizarre, almost magical rules of quantum mechanics and you match them up with the incredible learning power of AI, you get something that could totally reshape our world. But first, let's back up a bit and ask, why does AI even need this kind of upgrade?
To really see where we're going, we first have to get a handle on where we are today. We need to understand the limits of today's AI, both its incredible power and this sort of invisible wall it keeps running into.
I mean, think about it. AI is already everywhere, woven right into our lives. We're talking facial recognition, self-driving cars, even diagnosing diseases. These are absolutely amazing achievements, all built on classical computers that are just brilliant at finding patterns in mountains of data.
But here's the catch. There's a hard limit. Some problems out there are so complex, with so many variables, that they are completely, utterly unsolvable for our current machines. I'm not kidding. These problems would take our very best supercomputers longer than the age of the entire universe to figure out.
And this is where you can really see that wall. On one hand, yeah, today's AI is a genius at sifting through data we give it and spotting patterns we already know might be there. But on the other hand, it just hits a brick wall with problems of pure discovery. Things like perfectly optimizing a global supply chain, or simulating how molecules actually behave, or finding brand new patterns no one even knew to look for. This is where classical computers just run out of steam.
So how do we break through that wall? Well, we can't just build a bigger classical computer. We need a whole new way of computing. We need a quantum key to unlock a completely new paradigm.
Okay, so the first part of that key is a wild concept called superposition. You know how a normal computer bit is like a light switch? It's either on, a 1, or off, a 0. Simple. Well, a quantum bit, or qubit, is more like a spinning coin. Until it lands, it's kind of both heads and tails at the same time. Now, this isn't just a party trick. It means a small number of qubits can explore millions of possibilities all at once, giving them an insane processing advantage.
The second part is entanglement, which Einstein famously called spooky action at a distance. This is where things get even weirder. When qubits get entangled, their fates are linked. If you measure one, you instantly know the state of the other, even if it's miles away. This creates this incredibly powerful, interconnected web of processing power that grows exponentially with every single qubit you add. It's unlike any computer we have ever imagined.
And when you take these mind-bending quantum principles and you apply them to artificial intelligence, that's when you get quantum AI, or what some people call quantum machine learning. Look, this isn't just about doing the same old AI tasks a little bit faster. This is about completely changing the kind of questions AI can even begin to ask.
Okay, so how does this actually supercharge AI in the real world? Let's break it down into 4 key abilities that quantum computing really unlocks.
And you shouldn't think of this as just a list. It's more like a chain reaction. It all starts with enhancing machine learning at its core. That lets us handle way more complex data, which in turn allows us to generate better, more realistic data. And what's the end result of all that? What? We can finally start tackling those problems we once thought were completely and totally unsolvable.
This is where the rubber really meets the road. In practical terms, this is a total game changer. Just imagine being able to find the absolute perfect design for a complex neural network in an instant, instead of it taking months of trial and error. Or uncovering tiny hidden patterns in financial markets or scientific data that no classical computer could ever hope to spot. It could even mean creating perfect data to help design new, life-saving drugs. This is where all that theory becomes reality. So let's zoom out and look at the big picture. What does this all build towards? We're not just talking about improving AI anymore. We're talking about using it to solve the truly unsolvable challenges facing humanity.
Think about medicine. With quantum AI, we could actually simulate how molecules interact with perfect accuracy. We could literally design new drugs and new materials atom by atom.
Or how about robotics? We could build machines that don't just follow a pre-written script, but that actually learn and adapt to complex, unpredictable situations in real time. True intelligence.
And in the world of security and finance, this could lead to completely unbreakable encryption, while at the same time detecting complex financial fraud with a level of precision that is just unimaginable today.
And that really gets to the core of it all. This whole thing, this synergy between quantum and AI, it's not just a speed boost, it's a fundamental shift. It's about enabling entirely new ways of thinking and solving problems that, until now, were basically the stuff of science fiction.
Which leaves us with one final, fascinating, and kind of mind-bending question. If this technology can solve problems we can't, if it can see patterns we're blind to, and learn in ways we can't even comprehend, are we just building a faster tool? Or are we on the brink of creating an entirely new form of intelligence itself?